Hi students, this is a video for part H of question 1 on the 2016 Maths Admissions Test. So this is a question where on first inspection I'm really keen to try and avoid what looks like a load of algebra and calculus. Now sometimes that's a good way to think, and sometimes it's not going to give you any options to try and avoid it. I think it's always good to try and think of the geometry, and on this question you do need to have a bit of an understanding of the geometry, but ultimately this question sadly is unavoidable algebra and calculus. So we do need to have a bit of an idea of what this looks like, otherwise we're not going to have limits for our integral. F of x is a quadratic. It's got a constant term a, so that's an unknown constant, but we know a is positive. Tells us here. So if we think about what that looks like, since f of x is an even function, it's symmetrical about the x-axis, it's an inverted parabola, it's going to look something like that. And if we think about when f of x is 0, because we want to find the limits of our integral so that we can find this area here that's mentioned, we'd solve f of x equals 0, i.e. a minus x squared equals 0, which tells us x squared equals plus or minus a to the half. So we've got minus a to the half plus a to the half. And this is y equals f of x. Now, if I call this area A, the whole thing, I can find out what that area is in a moment, but let's have a look at g of x. Now, g of x is a quartic. If you're doing MAT to mirror, it is worth knowing what these basic polynomials look like. A quartic looks a little bit like a parabola. I highly recommend just drawing it on GeoGebra and Desmos and comparing the two. You'll notice that they intercept when x is 1. Not this particular one, but if you were just to consider generally y equals x squared and y equals x to the 4. But their behavior between x equals minus 1 and x equals 1 is really important generally for the MAT and the Tamura. So we draw our g of x, and that's going to look kind of like this. It seems to sort of flatten off a bit at the bottom. But nothing, it's not actually flat, but it looks flatter than a parabola. And so this is negative a. Now, similarly, we want our intercepts, and using a similar method of saying x to the 4 minus a equals 0, we can quickly arrive at minus a to the quarter here, a to the quarter here, and the area we want is here. I'm going to call that area B. Now, the issue here is that because we're comparing areas, well, when I integrate between these two values for y equals g of x, I'm actually going to get a negative value, but it's not the negative that I want to compare. I want to compare the area. So my area A is going to be integral of a minus x squared between minus a to the half and a to the half dx. But my area B is actually going to be the negative of the integral between minus a to the quarter, and x to the 4 minus a dx. And the reason for that is because this integral is going to give us a negative, and ultimately we want a to be bigger than b, which means we want ax minus x cubed over 3 between minus a to the half and a to the half to be bigger than the negative of, and be careful with this negative. I'm going to skip a few steps in a second because the algebra is quite long and you don't need to see a video of me faffing around with a load of algebra. But when you make those substitutions and you're careful with your negative signs, and there's negative signs all over the place here, and even for students at the level of going to sit the MAT or the Tamura, negative signs will still catch you out if you're not careful. But you will ultimately end up with, I'm just getting what I did earlier, this will end up with 4 over 3, a to the 3 over 2 is greater than 8 over 5, a to the 5 over 4. And we'd replace this 3 over 2 with a 6 over 4, so we know which side to, whether we're dividing by a to the 6 over 4 or the 5 over 4. Clearly, we'll divide by a to the 5 over 4, and with a little bit more algebra, will get us to a to the quarter is greater than 6 over 5, and therefore a is greater than 6 over 5 to the 4, which is answer E. It's E there. So this is just an annoying calculus algebra question, but you do still have to consider the initial geometry. And like I say, it's really useful for MAT and Temua to have a good understanding of what quartics, etc., look like. Those polynomials, have a good play on GeoGebra to see what they look like. Okay, hope that's helpful. Any questions, give me a shout. Thank you.